Hello viewers, welcome you in today's sessions on Techniques of Counting Part 2. It is based on Unit 4th of first course Foundation in Mathematics and Statistics of the program Postgraduate Diploma in Applied Statistics. In first session, we have discussed what we mean by fundamental principle of multiplication, fundamental principle of addition, fundamental principle of subtractions, and in today's session, first of all, we will give some notations for permutations and define how we evaluate some permutations of, and then combinations, and then in a given situation when we will apply permutation and when we will apply combinations, and we will discuss at last some important results. Permutation is a selection of the r things, suppose out of n things, and we have to arrange the things in a line. It is known as linear permutations. But if we are going to arrange the things on a circular, suppose there are sometimes in the meetings held in round table. So in that case, we use circular permutation. Permutation is the number of things that can be arranged, or things that can be arranged out of n, and its formula for this is factorial n divided by factorial n minus r. In first session, we have already discussed what we mean by factorial. Factorial is nothing but is the product of the first n natural numbers, and so factorial n upon factorial n minus r. After cancelling, because we can split factorial n as n into n minus 1 into n minus 2 and so on, and we can, after some factor, we will cancel this, and so we will remain with the factor n into n minus 1, n minus 2 and so on. Last term is n minus r minus 1. So the number of permutations of n things taken r at a time is nothing but we have to write r factors starting from n, n minus 1, n minus 2 and so on. We define n number of arrangements of n things taken 0 at a time is equal to 1, and by definition we have already defined npr is equal to this. This is the formula that we will going to use in this session. Let us take one example which will explain the how we work with the permutations. For 8p2 means we want to find out the number of ways 8 things can be arranged by taking 2 at a time. The formula for this is we have already discussed factorial 8 divided by factorial 8 minus factorial 2. Factorial 8 upon factor 8 minus 2 is factorial 6. Factorial 8 can be written as 8 into 7 into factorial 6. Now, after cancelling factorial 6, we have 8 into 7 is equal to 56. Similarly, 20 p5 can be written as 20 factorial upon factorial 20 minus 5 is equal to 20 factorial upon 15 factorial, and after splitting factorial 20, 19, 18 into 17 into 16 into factorial 15, after cancelling 15 common factor, we will get the desired result. Next, this 10p4 can also be written as this is another notation, and this can by definition can be written as factorial 10 upon 10 minus 4 factorial, and this is factorial 10 upon 10 minus 4 is factorial 6. After splitting factorial 10 into 9 into 8 into 7 factorial 6 cancel, so we are left with 10 into 9 into 8 into 7, and this comes out to be 5040. Meaning of this is we want to arrange 8 things taken all at a times. This is equal to factorial 8 by definition upon factorial 8 minus 8. Factorial 8 minus 8 factorial 0, and factorial 0 is 1, and factorial this is the value of factorial 8. So 8 things can be arranged in factorial 8 taking all at a time in 40,320 number of ways. And in last part, we want to arrange 5 things taken 0 at a time. So the formula for this is factorial 5 upon 5 minus 0 factorial. This is factorial 5 upon 5. This is equal to 1. To understand this, let us take one small example. Suppose we have only 3 numbers a, b, c, and we want to make the arrangements of the things taken 1 at a time. So we can take a, the one of the arrangement is a, or we can take b or c. So we have 3 arrangements a, b and c. So 3 can be written as 3p1. And if we want to arrange a, b, c 3 numbers taken 2 at a time, the arrangement can be a, b, b, a, b, c, CB, CA, AC. There are 6 in numbers, and 3P2 is equal to also equal to 3 into 2 is equal to 6. And if you want to arrange A, B, C taken all at a times, it can be written as A, B, C Let us take where we kept A as first position, then BC. Here we replace the values of B and C, CB. Then in next first we fix B as first position, then CA. Then in next we have replaced interchange C and A. And in last two first position we have fixed for C, then CAB, and in next AB is interchanged as BA. So there are 6 arrangements when all the numbers A, B, C taken all at a times, and 3P3 is also equal to 6. So that is the simple example that which match with the definitions. Next we talk about the linear permutations. Linear permutations we have already discussed in first slides. We are arranging the things in a line. Let us take an example. How many different words with or without meaning can be formed by using all the letters of the word equation without repetition? There are 8 letters in the word equations which are all different. Therefore, possible number of words by definition is nothing but the arrangement of the 8 letters taken all at a times. And by definition we have seen, and this is nothing but 8p8, and by definition 8p8 is factorial 8 upon 8 minus 8 factorial. 8 minus 8 factorial is 0, and this factorial 0 is 1. Factorial 8 upon factorial 1 is equal to factorial 8, and factorial 8 we have already evaluated. This is equal to 40,320. Let us take another example. How many signals are possible with 4 flags, each of different colors? For a signal, we can use one flag or 2 flag or 3 flag or all the 4 flags. So we have to consider all the possible ways. So let us take first count all the possible signals that can be formed with the one signal. Possible number of signals using one flag at a time. 4p4 equal to 4. Possible number of signals using 2 flags at a time. 4p2 is equal to 4 into 3, 12. Possible number of signals using 3 flags at a time. 4p3 is equal to 4 into 3 into 2. Because by definition we have written, if we have 4c3, we have write only 3 factors starting from 4. 4 into 3 into 2. And possible number of signals using all the flags at a time. 4p4. 4p4 means we have to write 4 factors starting from 4 into 3 into 2 into 1, that is equal to factor 4, 24. So therefore total number of signals, 4 signals can be made with the one signal using one flag at a time. 12 signals can be generated with using 2 flags at a time. 24 signals can be generated by using 3 flags at a time, and 24 can be generated using 4 at a time. So total we have 64 signals that can be found using the 4 flags. Another example is how many ways can 5 students sit in a queue? Because we are discussing a linear permutation, so that's why we are talking about the queue. Possible number of ways, total number of arrangements of 5 things taken all at a time. This is nothing but 5p5, and by definition factor 5p5 factorial 5 upon 5 minus 5 factorial. Factorial 0 is 1. This is equal to factorial 5. Factorial 5 is 120. Permutation of things not all at distinct. Suppose we have n things, out of them p1 are of one kind, p2 are of second kind, p3 are of third kind, and so on. Pk are of the kth kind. Then the total number of possible permutations are given by factorial n. Factorial n means total number of things divided by p1 were of first kind, factorial p1, p2 were of second kind, so we have to divide by factorial p2, and p3 were of third kind, and so on. Pk were of kth kind. So this is the general formula. Let us apply this formula in an example. How many different words with or without meaning can be formed by using all the letters of the word banana? There are 6 letters in the word banana, and out of which A and N occurs 3 and 2 times respectively. So here all words are not distinct. So total number of words is 6. Here value of if we compare with the previous formula, value of n is 6, and value of p1 is 3, because there are 3a, means 3 numbers are of one kind, and there are 2 n's, and so there are 2 things of second kind, so we have to divide by factorial 3 into factorial 2, and after simplification factorial 6 can be written as 6 into 5 into 4 into factorial 3. Factorial 3 cancel with factorial 3, factorial 2 is 2, and after simplification we get 60. Next, permutations with repetition is allowed. Prove that total number of permutations of n things taken r at a time. Things can repeat any number of times is given by n is to power r. We have to, this is the journal result. Let us prove this result. In order to find out total number of permutations, we have to fill up r positions, where first position can be filled up in n number of ways. Second position can also be filled up with n number of ways because repetition allowed. We can also repeat the digits that we have already used at first place. Third position can be filled in n ways because repetition allowed, and so on. Rth position can also be filled with n number of ways. So by fundamental principle of multiplication, that says if we have to do n jobs, first job can be completed in m1 number of ways, second can be completed in m2 number of ways, and so on. Nth job can be completed in mn number of ways. Then the complete job can be completed by number of multiplication of their individual options. So here the first position can be filled up with n number of ways, second can also be filled up n number of ways, then into n into n, this is equal to n is to power r. This is the result that we want to prove. Let us apply this result in a example. In how many ways 5 letters can be posted in 3 letter boxes? Here we have 5 letters and 3 boxes. So each of the 5 letters can be posted in 3 ways. Suppose there are 3 letter box A, B and C. The first letter can be posted in letter box A, or first letter can be posted in letter box B, or first letter can be posted in letter box C. So for first letter there are 3 options. Similarly, for the second letter there are 3 options. For third letter there are 3 options. For fourth letter there are 3 options. For fifth letter there are 3 options. So if we apply the previous results, or by a fundamental principle of multiplications, we see that required number of ways is equal to 3 into 3 into 3 5 times. 3 is to power 5, and 3 is to power 5 is nothing but is equal to 2, 4, 3. Now we come to on the circular permutations. In linear permutations, what we were doing is we were making the arrangement on a line. But if we were interested in forming the arrangements on a circle, because suppose there are a round table meeting. In round table meeting, the person sits around a table. So, and if we want to count the how many number of ways are there, suppose there are 10 persons in a meeting and they are going to sit around a table, and if we want to count how many ways those 10 members can sit around a table, those type of situations, the circular permutation is used. Suppose we have A, B, C and D. There are 4 letters, and we want to arrange we can arrange these 4 letters in a line as A, B, C and D. Line means we can at first place we can put letter A, then B, then C, then D. And in second arrangement, in case of linear at first place we can put B. At second place we can put C, then D and then A. And third is at first position we can put C, then D, then A, then B. And fourth linear permutation can be first letters at first place we have put D, then A, then B, then C. There are 4 different ways for a linear permutation. But note in these figures, here in this circular diagrams, all these 4 linear arrangements are the same things, because if we see A, B, C, D, let us start from here. A, then B, then C, then D. Then next is B, C, D, starts from B, B, C, D, A. And third is C, D, A, B, and C, D, A, B. And fourth is D, A, B, C, D, A, B, C. These were 4 different linear permutations. When we represent them on a line, we have 4 different ways. But when we represent this on this round table, these 4 linear permutations make only one circular permutations. And let us move ahead, and we see that we have already seen in the previous slide that we in case of 4 letters we have 4 linear arrangements, and 4 linear arrangement is equal to 1 circular arrangement. Therefore, 1 linear arrangement is equal to 1 by 4 circular arrangements. So, factorial 4 linear arrangements is equal to factorial 4 upon 4, and factorial 4 can be written as 4 into factorial 3. 4 cancel with this 4, we are left with factorial 3. This is a particular case. Let us take a general case. Suppose we have n, if anti-clockwise and clockwise order of arrangements makes different permutations. We are taking into account that anti-clockwise and clockwise both have the both are different arrangements. Then number of circular permutations of n things is equal to factorial n minus 1. In previous case, we see that n was 4. So 4 minus 1 is 3, factorial 3. This is the general formula. If we want to arrange n peoples around a table, then the possible number of ways that they can sit is factorial n minus 1. Then if anti-clockwise and clockwise order of arrangements does not give distinct permutations, then total number of permutations of n distinct things is half, because the total of circular permutation were factorial n minus 1. But if anti-clockwise and clockwise does not make different arrangements, so we have half arrangements, half of the total arrangements. So in that case we have factorial n minus 1 by 2. For example, arrangements of the flowers in a garland form the same permutations in case of anti-clockwise and clockwise order. Let us take an example. In how many ways 10 students of a batch can be arranged in a line? This is line means we are talking about the linear permutations, and in a circle means we are talking about the circular permutations. Total number of arrangements of 10 students in a line we have already seen. When we talk about the linear permutations, n things can be arranged in factorial n number of ways. So here value of n is 10. So 10 students can be arranged in a line in factorial 10 number of ways. This is equal to 36,28,800. 10 students can arrange in a line in 36,28,800 number of ways. This is the linear permutation. Now if we come on the circular permutations, we have already seen the general formula. General formula is if we want to arrange n students, n things in a round table, then total number of ways is n minus 1 factorial. Here value of n is 10, so 10 students can be arranged in around a circle is factorial 10 minus 1 factorial means 9 factorial, and 9 factorial it comes out 3,62,880. Here we have less number of arrangements compared to the linear permutations. The last topic of this session is combinations. In permutations, what we were doing is we were forming the arrangements. It means order matters. A, B and B are different things. But if we are interested in forming groups, in that case we form combinations, and the formula for combination is NCR. If we want to groups n things taken R at a time, the formula is factorial n divided by factorial n minus R into factorial R. And in particular case, if we have 3 letters A, B, C, and if we taken 2 at a time, this can be written as A, B, B, C, C, A. Recall in case of the permutations, taken 2 at a time, we have A, B as well as B, A, because their order matters. But here in combination, order does not matter. And this 3, C2 comes out to 3, and A, B, B, C, C, A, this is also 3. And in total number of combinations of A, B, C taken all at a time are given by A, B, C. There is only one group with the 3 letters A, B, C, and if we solve 3, C3, this also comes out to 1. Let us take one example. If 4 cards are chosen from a pack of 52 playing cards, then find the number of ways that all the 4 cards of different suits of same suits. We know that there are 52 cards and there are 4 suits, 13 cards of each. and we are interested in all the 4 cards of different suits. So either the 4 cards may be of the first suit, maybe diamond or heart or club or spade. So 13 C1, 13 C1 we have already calculated. This is 13, and the 13 raised to power 4 is 28,560. And required number of ways in a second part of the same suit. All the 4 cards should be of same suits. So either they may be of the spade, or all they may be of the heart, diamond and club. So this is equal to 4 times of this, and after simplification we get 2860. And if we want to know whether permutation will be applied or combination will apply, we have to see whether the order matters. Suppose we want to form the numbers of 2 digits. If we have 2 digits 4 and 6, we can form letter 46 and 64. Here order matters. If we write 4 at tens place and 6 at units place, we have 46. But if we replace their positions, if we write 6 at tens place and 4 at unit place, we have 64. In this case we will use arrangements. Arrangement means permutations. When the order matters, we will use permutations. When order does not matters, we only talk about the groups, then we will use combination. And the last result of today's session is suppose total number of permutation of n distinct things taken are at a times, and if s particular things are always included, means what we have to do is s things are has already been included, so remaining r minus s, because we want to select r things, but s things are has already been selected. So we have to select r minus s things out of n minus s things. But those s things can also be arranged in rp s number of ways. And if s particular things are always excluded, if we exclude s things that cannot be included, then we have to select r things out of the n minus s things. Another result that is if a total number of combinations, that previous result was related with the permutations, but in this case if we have combinations, then instead of p we have used here c, and here we forms groups. In previous case we form arrangements. Let us take one example and find the total number of ways of selection of 15 players out of 21 players, such that 3 particular players are always included. Let us take solve this example. 3 particular players are always included means we have to select 15 minus 3, 12 number of players. Out of total players were 21. So out of 18 players we have to select only 12, because 3 have already been selected. So this can be written as this can be required number of ways 18c 12. After solving this, we have 18,564. And if we apply that result that we discussed this, the here value of n is 21 and value of r is 15, value of s is 3, and after applying this result we will get the same result. And the second part, after 2 players always excluded means 15 players we have to select, but 2 players cannot be included, those we have to exclude. So out total player were 21, so we have to select out of 19 players. So after 19c 15, after calculating this we get 3876. And if we apply that results, where a value of n is 21, r is 15, s is 2, and after applying that results we get the same results. Let us summarize today's sessions. In first we discuss what we mean by permutation. Permutations means we want to count the number of ways, how many number of ways and things can be arranged in taking r at a times. Then we talk about the combination. In combinations we form the groups out of n things. If we want to select r things at a times, how many groups can be formed? And in that case we use these combinations, and in case of the arrangements we use these permutations. So that is all about today's sessions. Thank you learners to be with us.